Physics students, if you are in exam hall and you come across this type of question, don't fear, solve it. It is a simple question. Let me show you how to solve it. Let's read the question first. The question says, a block of aluminium of mass M is heated electrically by 25 wattage heater. If the temperature rises by 10 degrees Celsius in 5 minutes, calculate the heat capacity of the aluminium. So you go. Get started. What is happening here is simply the practical application of the theory of energy, which we know, which says that energy can never be created or destroyed, but can be changed from one form to another. Here, heat energy is being changed from one form to another. That is, electrical energy is being changed to thermal energy. And this is what we refer to as heat gain equals to heat loss in physics. Heat gain is equals to heat loss. Aluminium is gaining heat from electricity. Let's first of all write out the data so that we know the formula to use. So write out the data. Okay. Mass, which is represented in physics by M, is what? Oh, they did not give us the mass. They give us M as mass. So we see M kilogram. Okay. Which other data? They say that it is heated electrically by 25 watts. Okay. So power, the wattage, is 25. So you have written the mass and you have written the power. Okay. What other data is given to us? The temperature rises by 10 degrees Celsius. So temperature change, which is denoted by theta, is 10 degrees Celsius. Is there another thing given to us? Yes. Time, 5 minutes. So we write time, which is T, as 5 minutes. Okay. Don't forget that you cannot solve this question on minutes because the standard unit for time is second. So let's change this time to second. It now becomes 5 times 60. 5 times 60, which will give us what? Which give us 300 seconds. Okay. Now I want to solve the question now. I want to solve it this side. Remember I said earlier that this is the practical application of the theory of energy, which says that energy can neither be created nor destroyed, but can be changed from one form to another, which we simply put as heat gain is equals to heat loss. Here, electricity is giving heat to aluminium. Electricity, which is 25 wattage, is giving heat to aluminium. Yes, which means electric heat energy is being transformed to thermal energy. Let me write it out. I say heat energy is being transferred to thermal energy. Heat energy. Electric heat energy is electric heat energy is being converted to thermal heat energy. Okay. And the electric energy they give us here is power and the time 5 minutes. So we say power WT, which stands for electric energy, is equals to MC theta. This one is for thermal heat energy. Okay, I want to substitute this value into this formula. So I write 25 times our time. We say that our time is 300. 5 times 60, 300 seconds, times 300 is equals to, what is the mass given to us? They don't give us the mass, but because they asked us to calculate the heat capacity, we now know that the mass should be 1, because the specific capacity of any object is the heat that is required to raise 1 mass, 1 kilogram of that object. So we write M as 1. Okay, times this C, we are looking for it, we are solving to get it. specific capacity, C, times temperature change, which they give us as 10. Temperature change 10. See it here as 10. So we are times 10. Okay? We continue. We come to this side. We evaluate this side. We say 25 times 300. It gives us 7500. Put our equals to. And we say 1 times C, still 1C, times 10, it becomes 10C. Okay? Since we are solving to get the value of C, which is the heat capacity of aluminium, we make it the subject formula. So we say this C now. C, write this equals to, is equals to, write this 7500. 7500 over the number with C now will come down over 10. And if we evaluate it finally, we have that C is equals to 7500 divided by 10. Just cancel this 10 and 10. And what remains is 750. So I write equals to 750. 750 joule Kelvin bar 1. Answer. Yes. So the heat capacity of the aluminium in this question is 750 joule Kelvin bar 1. Yes, it's a simple question.